going to describe the graph of a cosine, very similar. And then we put both of them together. And there are some format of this graph that's going to be used for application, and we are going to be interested in. Okay, so we are still in that section 4.1 and 4.2. Okay, so let's describe the graph of the sine, the graph of the cosine, the graph of y equal to the cosine x. The situation is going to be the same thing. You know, we talk about the domain of this function. It's defined for all real numbers. Okay, so the domain is the same as the domain of the, okay, the domain is going to be negative infinity and positive infinity, or just, it depends, for defined for all real numbers. Okay, so this is going to be the case. And the second property is going to be the range. We talk about the range of these two functions are going to be between -1 and 1. So this means the cosine of theta, or x, is always between 1 and -1. Okay, this is going to be true for all x's. Okay, so this is going to be the range. This is going to be for all x, and we use it in calculus quite a lot because of the unit circle. Okay, this is the other thing is we talk about it. Remember, the cosine of the negative x is the same as the cosine of x. So go to the right, to the left, you are going to be on the same graph. So this means this graph is symmetric respect to the y, and the function is the function, so the cosine function f of x equal to the cosine x is even, and the graph, okay, and the graph is going to be symmetric. That would be useful, symmetric with respect to the y-axis, with respect, okay, to the y-axis. You know, y-axis would be like a mirror. Okay, this is it. And part 4, if you just okay, if you let cosine x equal to the 0, you know that the 0 is the cosine of the pi half, 3 pi half, pi half, etc. So this means those numbers are going to be the x-intercepts. Okay, so the x-intercepts are going to be x equal to, okay, x equal to the pi half. It's going to be 0 at this point. Okay, 3 pi half, and then just a 5 pi half, etc. So the graph would intersect the x-axis at these points. And the y-axis, if you want the y to be equal to the, okay, this is going to be when x, then you get the y-axis. If you put x equal to the 0, cosine 0 is 1. Okay, so the y-intercepts is only, okay, is going to be equal to 1. Okay, that's 1. The maximum value is 1, and the minimum value is okay, so the max value at most, the max value, or the maximum value is going to be a positive 1, and the minimum value, we're going to talk about the range, so it's going to be a minimum value is going to be a -1. Okay, so this is a situation we're going to have. And you know that the period of the the period of this function is going to be equal to the 2 pi. So cosine is periodic. The t is equal to the 2 pi. And in general, whatever we did for the sine is true for this one. In general, if y is equal to the cosine of, we already talked about it. Okay, it's going to be equal to the, let's say, a cosine of the bx, then the period of this function is going to be 2 pi over b. Exactly the same thing that we did for the for the sine. Now the graph can be nicely given. Okay, so this is going to be the graph of the y equal to the cosine x is given by, you see, that would be exactly the same thing that we did, similar to the cosine. So there you are. You see, in one period between 0 and 2 pi, we divide it into 4 again to find those crucial, critical interval. If you divide it into 4, so that give you pi. Okay, that give you pi half. And this is going to be 3 pi half. Okay, pi half, 3 pi half. In the case of the sine of 0 is 0. So we start from the origin. But in the case of the cosine of 0 is a positive 1. So the cosine of 0 is positive 1. So we start from the top. So that's it. That's going to be the difference. Okay, that's a positive 1. And this is going to be a negative 1. Okay, sine of 0 is 0. You must start from the origin. But the cosine of the 0 is 1. So you start from the top, as we did with the sine. You see these 4 intervals that we have. So we start from the top here. Okay, then you get to the first part, which is going to be intercepts. So it's going to be intercepts. You know that the cosine of the 90 is equal to the 0. Then you get to the next one that give you a minimum. So the minimum would be at pi. We get the minimum here. Then you go to the next one, which is going to be an intercept, and you end up with a maximum. With a maximum, okay, would happen at 1 here. Okay, so this is a situation you're going to have. So you start from the top, you see going down to the minimum. Then you go to the intercepts and you end up with the maximum. So this is going to be the graph of the cosine of x. Very easy graph to consider. Okay, so make sure that you start. It may start from the top or bottom, depends. It's a cosine x, you start from the top. If it's going to be negative cosine x, you start from the bottom. But 4 crucial numbers that we have, you see, intercepts, pi half, minimum at pi, intercepts 3 pi half, 270, and the maximum at 2 pi. Okay, so we start from the one, intercepts, minimum, intercepts, maximum, done. If you want to extend it, this is just one period. If you want to have another period, you have to repeat it. You may repeat it to the right, or you may repeat it to the left. If you want to repeat it to the left, you see this is the one. So we are going to create a negative 2 pi here. Okay, then this is going to be a negative pi. And this is going to be negative pi half. And this is going to be negative 3 pi half. Those 4 crucial numbers. Then you have to repeat this one. So how are you going to repeat it? You see, you start from the top, you get to the first portion, first number. The first number is a negative, okay, negative pi half. So this is going to be intercepts. Then you go down, you get a minimum at negative pi. So the minimum at negative pi. The next number, negative 3 pi half, give you the intercepts. And the next number, negative 2 pi, must give you a maximum. A maximum at 1. Okay, a maximum at 1. So you repeat the graph. If you repeat the graph, this is it. You see, you get to the intercepts, you get to the minimum, the intercepts, and up. You see, it's just a repetition. It's just repetition of that term to the right. So sometimes they may ask you for one cycle, one period, you are done, one period. If they ask for 2 period, you copy this one. You can copy to the right, copy to the left, or forever. So this is going to be the graph of the cosine in 2 period. Okay, any question? Very popular graph. Okay, many applications
Teacher,
like the sine. Just make sure you know the
please,
difference.
teacher,
Now the
teacher,
situation that we did for the sine is going to be coming with the cosine.
teacher,
You may not have, you are not, this is it, this is cosine x. But we usually change it. You may change it to
teacher,
the, okay, we double it, cosine 2x, 4x,
teacher,
cosine 1/2, a quarter, or some other, properties that I'm going to explain it. But
teacher,
this is the model. You may shrink this model, okay, or you may expand this model, but basically the situation is going to be the same, okay?
teacher,
Everything would be the same.
teacher,
So you can't hear me?
teacher,
Yes,
teacher,
tell me in a minute.
teacher, can I ask you a question?
Sorry.
Please,
Yes.
teacher, teacher, teacher.
Yes.
I don't know how I will send my test.
Okay, email it later on. Don't worry.
I put it up. I couldn't.
Don't worry. Try it again. Okay, I'll give you time to submit it. Email it to me. Like the one that you did for the quiz. You did very well on the quiz. That was a nice one that you sent me. I tell you after the lecture, I can help. Okay, just listen to the lecture. You can do that one later. Okay. I'm sorry. So, can you hear me now? That's one. Just let me know. Okay. So we are going to give you a couple of more examples. Okay, this is the model. We just switch it in different formats. You see, I didn't use any table, any charts, and I did it because we want to learn it in this format, especially if you want to go and teach, get calculus 1 and 2. That will help you quite a lot to get this type of ideas. When we work with the function, we have something we call polar polar coordinates. I'm going to talk about it for you at the end of this course. In those type of graph, these type of techniques would be very helpful to get it. Okay, so let's get a couple of examples of the different format of the cosine. So as usual, you saw 2 on your test. And then you get to your next quiz, you see the cosine. So the example is going to be, you see this is example. So we wanted to sketch the graph of each function. Sketch the graph of each function. Okay, the first one is going to be f of x equal to -2, okay, -2 cosine of the 4x. You want to try this one? It's a cosine function, okay? So identify the period of your function. Solution. You see this b is equal to the 4 if you like. So the period of your function is going to be 2 pi over b. Okay, 2 pi over b, which is going to be 2 pi over 4. Okay, we simplify it. That gives us what? That gives us a pi half. Okay, so you have to graph this function in a period of what? You see, one cycle is going to be between 0 and pi half. 0 and pi half. Remember, we divide into 4 parts. You can do it right away, or you can just, uh, check it for yourself. I just do it so that you know it's the same procedure. So we divide this interval into 4 sub-intervals. The length of each interval must be pi half divided by 4, which is going to be pi 8. Okay, which is going to be pi 8. We can do it. I just do this one so that you see it. So you start from the 0. You go to the, okay, you go to the pi 8 for the first one to get these numbers. Okay, this is going to be the case. Okay, it's a multiplication 4 times pi. So what we're going to do is the first interval is going to be, you start from the 0, 0 pi 8. I do the algebra first for you. Okay, that's going to be the 1. So the next interval is going to be pi 8. Okay, this is going to be pi 8. You see the pi 8 plus pi 8, which is 2 pi 8. 2 pi 8. Then simplify it. Then the next one is going to be 2 pi 8. Okay, then the 3 pi 8. Okay, and the next one is going to be, this is 3 pi 8 and the 4 pi 8. 4 pi 8. This is algebra. And if you simplify it, you see you have a 0 and pi 8. That's the first one. The second one would be pi 8 and the pi half. And this is going to be pi half. Okay, and the 3 pi 8.
Professor, wouldn't it be pi over 4?
Which one?
The second one, pi 8, pi over 4,
You
and
are
then pi over.
right. Very good. Yes, you are right. Thank you. Thank you. Pi 8 is 22.5. That's 45. Yes. So the next one is going to be pi 4, 3 pi 8. Thank you. Okay. So this is going to be 3 pi 8 and the what? And the pi half. Remember, we like to get to the, okay, get to the pi half. These intervals are going to be very useful in applications because you get the maximum minimum for these numbers. So I just did it, but if you want to, when you want to graph it, this is it. So in one cycle, if you like, say that's going to be the one. So you know that you have to go 0 and pi half. This is your one cycle. So this is going to be 0, and this is going to be the pi half. Again, you divide to 4 parts, and then that's it. So this is going to be 1, 2, 3, 4. You have to give us these numbers if you don't want to write this, but at least you identify it here. Okay, that's going to be 0. So this is your pi 8. And this is going to be a pi 4. This is your 3 pi 8, and eventually pi half. Now you have to decide what are we going to do, what's going to be up and down. We know that this is the range, if you like. This is going to be 2 in general, but then we decide about the positive 2 or negative 2. So at most you go up 2 units. Okay, so this is going to be a positive 2, and at least you may go down negative 2. That's, remember, that's the minimum and the maximum value of your function. That's it. It's a cosine function. Since it's a cosine, you may start from the top or you may start from the bottom. You just check what you have a negative 2. Since you have a negative 2, you must start from here. Okay, so you must start from here. So that's going to be the starting point. Okay, then you know that you go to the intercepts. The first one would be intercept. The second one would be up. So this would be up. Okay, so this is it. It starts from here, intercepts up, then intercepts again, and you end up here as a minimum.
Professor, I have a question.
Yes,
When would you start, I guess you could say the origin, like a 0, 0? When is that for sine?
that's for the sine. Yes,
Oh, okay. All right.
yeah, because the cosine of the 0, you know, that is 1. So that's the difference. The starting point end is going to be different. Okay, so now this is it. So we identified that this is going to be the case. Okay, you're going down and you end up here. Okay, so this is going to be the graph of your function in one cycle. Any question? Without any calculation, you know that this is going to be, the function is going to be 0 as pi 4 and then 3 pi 8. Your function would have a maximum, at x equal to the pi 4. And the value of that maximum value is positive 2. You see? Your function would have a minimum at x equal to the pi half, and the minimum value of your function is going to be negative 2. So the minimum would be at x equal to the 0, which is a negative 2, and at x equal to the pi half. You see? This information, automatically you will get it without any calculation, if you like, to get these numbers. Any question? This is in one cycle, okay? If you want to repeat it, you just, pick which direction you want to go in. They ask for 1, it's done. But if you want to go with the second, you just mirror image, because this is symmetric. Mirror image, this is a mirror here, the mirror image over here. So the mirror image would be, this is a negative. They didn't say anything, so we are done. If they say in 2 cycle, okay, 2 period, then you just get the mirror image here again. So this is it. Okay, these are going to be your 4 points, and then you can continue. You know that you have to go to the intercept here, then you have to go to the maximum, then you have to go to the intercepts, and eventually you get to the, okay, you get to the minimum. So this is going to be your graph in the second period. You see, it's a copy of the first one, and you can go on forever because your function is periodic. Okay, any question? So you don't need anything else to worry about, but this is very important in future. You will see even in this course, we're going to have the inverse of the cosine function later on, application in calculus. Which of these are going to be better? You will see it. But if you want to get the feeling, just quickly be able to get to draw, a sketch of your graph. Then you see, then you may worry about the other problems that you're going to have. Okay, any question? So that's one format. The other format that you got it on the test, this is popular for physics application. In the application, they are going to give you this type. It's when talk about angular velocity, these type of things. So it's a 3 cosine of the pi x. Okay, the pi x, 2 pi x, 3 pi x, etc. We have something in physics we call it Euler equations. And when we want to solve it, we end up with the cosine of the pi x and the sine of the pi x. The solution, of course, coming from calculus. Okay, so there you are. So identify the period of your function solution. That coefficient b is equal to the pi. So the period is going to be a portion of the 2 pi over pi this time. You simplify that, give you 2. Okay, that give you 2. So one period of the for graphing is going to be 0 and 2. Okay, you divide this one into 4 subintervals if you like, and you know that you just divide the 4 by 2 by 4, and you break it into parts. Okay, so it's going to be your 2 divided by 4. 2 divided by 4, that gives it 2 quarters, which is going to be half. So that's the length of those subintervals that we're going to have. So those crucial intervals are going to be, you start from the 0, then you go to the 1/2. Okay, then you add the 1/2 to get rid of it. It's going to be the first one. The second one is going to be 1/2. It's going to be 1/2 and 2/2 if you like. I write down, you know how to check this. Okay, that's going to be the one. Then you start with the 2/2, then the 3/2, and eventually this is going to be the 3/2 and the 4/2. Okay, when there are going to be pi involved, this type of interpretation would be useful. So basically the intervals are going to be 0/2, 0/2, and this is going to be 1/2 and 1, and this is going to be 1 and 3/2, and you get a 3/2 and 2. Again, when you want to graph it, you just identify these on that, okay, on your graph, we accept it. We just wanted to see the situation they're going to have. And again, they are going to give you the intercepts and the max and the mean. In the application problems, they are going to ask you for that. Okay, so we can graph it here. This is it. So this is going to be x, y coordinates. So the interval of 0, 2. So this is it. This is going to be 0 and 2. And you divide it into 4 parts, and you know the parts already. So this is it. Okay, you know that's going to be 0/2, and this is going to be 1, and this is a 3/2, and eventually 2. Then you identify the range. It's a positive 3 here. Okay, 3 up is going to be 1, 2, 3. So this is the most that you can go. And again, this is going to be, okay, 1, 2, 3. And this is the least that you can go. Okay, it's a cosine function, so it's not going to be starting from the origin. Since you have a positive 3 here, so we start from the top. Okay, so you start from the top. This is going to be the starting point for your graph. And then you go down, you go to the first portion, which is going to be intercepts. You get the minimum at 1. Okay, you get the minimum at 1. Then you get the 0 intercepts at the 3/2, and you get the maximum value at 2. So this is going to be the graph of your function. You see, that's going to be the graph of the cosine. Okay, again, it's nicely done without any operation. And you can tell us quickly that the function would have a maximum at 1, sorry, a minimum at 1, and the minimum value is -3. You see, minimum value -3. The function would have a maximum at 0, which is equal to the 3, and at 2, which is equal to the 3. And the function would have the value of the 0 at 1/2 and the 3/2. You see, all the information quickly can be identified, which is very, very nice. Okay, any question? Now, cosine is very popular for the application in physics. So we give you one application problems in physics. So I'm going to give you one to see what's going on. Any question? So just make sure that you know the difference between sine and a cosine and the starting point. Look at this one. The coefficient was negative, so we get the -2. That's why we start from the bottom. Okay, we start from the bottom. But when it's positive, you start from the top. Top, down, you see, you get the result. Okay, question? So let's quickly how we apply it in science. We give one of these problems, which is very popular problem. Okay, it's all these phenomena in electricity that we're going to have, or in mechanic, would follows a kind of a cosine or sometimes sine equation. So we pick one of them and we ask you some question. Okay, so this is it. Example. And the example is going to be this one. We talk about the voltage in a household. I have to write it down. And so this is it, the electricity or the voltage. Okay, in a household. Okay, the household electrical. Okay, electrical outlet. Outlet is given by okay, it's given by V of, this is going to be V of T, the voltage. Okay, is equal to the 170. Okay, 170 cosine of 120 pi t. Okay, this is going to be the t is going to be the time, and the V is going to be your voltage. Okay, so this is how you are going to be charged, for example, where V is measured. Okay, this is measured in volts. Okay, the units, and the T in seconds. T in seconds. Okay, so what do you want? What they want, the first part, they usually ask for the range and the domain. Okay, so they ask you to specify. Okay, specify the amplitude or just the range or amplitude. Okay, and the period and the period. Okay, you know that this coefficient, of course, with the absolute value, because you want it to be positive, 170 is denoted by A. That's going to be the amplitude, and then we identify the period. The B is 120 pi. Then it's going to be 2 pi divided by. We are going to do it. Let's write down all parts of the question. Then we're going to do it. Then they ask you to graph it. Okay, they ask you to sketch the graph. Okay, sketch the graph. Okay, the graph of that function that we talk about it, of v of t, if you like, of v of t. They ask you for 2 periods. Okay, for two complete cycles. Or this is going to be just periods. Okay, beginning. You want to begin at the beginning. Okay, it's going to be beginning at t equal to the 0. It's going to be 0, and because you can have a different format. Okay, so this is going to be the case. Now, then there is an application question, which is the last part. You see, the last part is, that's interesting. They ask you for which. Okay, that's it. For which values of t, for which values of t, the time, in part B, when we graph it. Okay, in part B, this function is a maximum, is the voltage, the voltage. Okay, voltage maximum, a maximum, or maximum. Okay, so there are going to be sometimes that the voltage would be in its maximum value. So what we are going to be interested in, we are interested to identify it for us. Okay, in calculus, we have other tools to find out, okay, the maximum and the minimum. But over here, we get it free because we graph it. We graph it, as I told you, those techniques, those measurements that we did, that will tell us exactly when we get the maximum or when we get the minimum, those crucial intervals. Okay, any question? Are you ready? That's it. So this is it. A function is given to you. It's voltage this time. Next time, maybe something else. Okay, so let's get the solution. So we have the function. We already talked about this coefficient. The absolute value of this number is going to be the range amplitude. Okay, it's positive. So we are going to claim that the A is going to be equal to the 170. Remember, if it's going to be negative, you have to use the absolute value. This is it. In all the problems in your book, they ask for this one first. Then we have to find the period. Okay, B, the coefficient, usually we go for it. So that B is 120 pi. Okay, so the period of a cosine is 2 pi, but it's going to be portion of the period, it's going to be 2 pi over B. Okay, you substitute. So it's going to be 2 pi over B. B is 120 pi. Okay, 120 pi. I simplified, the pi would disappear, and that give you what? That will give us 1 over 60. So it's going to be 1 over 60. So the period of this function, is going to be what? It's going to be 1 over 60. Don't use your calculator. You have to write it down as is. Okay, so this means one cycle of this graph is going to be what? So the one cycle is going to be 0. Okay, 0, comma 160. This is the period that you have to use in order to grab it for this function. Any question? Now you know that you have to decide how we're going to get from 0 to 1 over 60. When we graph the function, you know what to do. We know that we have to divide into 4 parts and then go for it. So let's see what is going to be the length of each part that we're going to have. So we have to divide this 160 by 4. You see this is going to be 1 over 60 divided by 4. You know that it's like, it's a fraction. So it's like, see, this is going to be 160 when you divide 2 fractions. Remember, you write the first one, you multiply by the reciprocal of the other one, which is going to be a quarter. So the result is going to be 1 over 240. So this is going to be the length of each interval that we're going to make. Okay, you are going to make those 4 intervals or sub-intervals start from the 0. So let's see what is going to be those intervals that we're going to have. Okay, so the first one is going to be 0. Okay, 0 and 1 over 240. Okay, remember we need 4. So the next one, what's going to be the next one? The next one is going to be 1 over 240. That's a measurement. That's a ruler. Okay, and what? 2 over 240. Each section. Okay, move on. The length of each is 1 over 240. So what's going to be the next one? The next one is going to be 2 over 240. Okay, comma what? 3 over 240. 3 over 240. 1, 2, 3. What's going to be the fourth one? The fourth one is going to be 3 over 240, comma 4 over 240. You see, that's a situation that you are going to know, you're going to have. Okay, you can now simplify it to get a better numbers. So if you simplify that, give you 0 and it's just 0 on 1 over 240. Okay, so the next one is going to be 1 over 240. And if you simplify this one, that give you 1 over 120. Okay, and this is going to be 1 over 120. And this is going to be 1 over 80. Okay, 1 over 80. And the last one, in fact, if you keep these numbers, that would be more helpful when we want to graph it, but at the end, we have to simplify it. Okay, so this is going to be 1 over 80, and we have 1 over 60. You see, as we predicted, you must get from 0 to 1 over 60. This is 0, and this is 1 over 60. Any question? So be careful. It's not difficult, but when it's application problem, you have to go through it to get these numbers in a proper place. Okay, now we graph it. Seems to be complicated, but it's not, because the idea of the graph is interesting. We know what to expect. Okay, so this is it. So let's graph. You need 2 periods, so make sure you have enough room to do it. Okay, so I go with this one. Okay, this is going to be the case. And so what I'm going to do is, because I need 2 period to go on, so my first period would be between 0 and 1 over 60. So I'm going to pick this one to be 0. Okay, 0, and let's say this is going to be 1 over 60, because they asked for 2 periods, start from the 0. So this means we are not going to go to negative, because t is the time is not negative. Okay, so that's why. So 4 parts as usual. So this is going to be the 4 parts. Okay, 1, 2, 3, and 4. Okay, this is it. No, going up and down, what do you have? You have 170. You see, you have 170. So, just pick something like, suppose this is 170. Okay, this is going to be 170. So down here, this is going to be negative, if you like, 170. Because you have to decide, that the max and the minimum, you need both of them. Okay, so now what's going on? So the coefficient of the cosine is positive, 170 is positive. So you start from the top. You start from the top. Remember, at the first number, you are going to have the intercepts, and the second number, you are going to have a minimum. So this would be the minimum. The minimum would happen at this point, and then we get the intercepts here, and then you get a maximum here. So the maximum value would be this one. Okay, that would be the maximum. Okay, any question? I'll get the first portion. So the first portion is, this is cosine, start from the top. Okay, start from the top, intercepts. You get to the minimum, you get to the intercepts, and you get a maximum. That's going to be your graph in 1 second. As you can see, this is the cosine. It's a cosine, but the measurements are going to be the same, are going to be different. Okay, and the situation is that you got these points if you wanted. You know that this is going to be 0. This is 1 over 60, and that take you down here. Okay, so as you can see, this graph, it's the highest point, highest value is going to be at 0, which is 170. Okay, then you get the maximum at here, which is going to be, you see, when t is equal to the 160, when t is equal to the 160, the value of the function is 170 because of this point. You see this point? This point here is what? This point is 160, comma, as a point, 170. You see, that's what. So this means if you put t equal to the 160, you get 170. And this point over here is going to be the same thing. This point over here is going to be what? The x is, okay, this is it. So your t is equal to the 0. So t is equal to the 0, but the value of the function is maximum, 170. Okay, so This means the maximum value. The maximum value would happen at what? At t equal to the 0, we get the maximum, and at t equal to the 160, okay? So they ask for the 2 cycle. Let me just complete the 2 cycle. They ask for the 2 cycle, but it's starting with 0, so we have to go to the right. So copy this one here. Okay, this is 160. So what we can do is we can pick another one. So I pick the 4 here. Okay, that's it. Just divide into 4 parts. Okay, you have to continue. You see, this last one was what? You see, the last one was 4 over 240. If you want to see this number, it's going to be 5 over. You see, that's going to be 5 over 240. If you want to see it for yourself, 5, 6, 7, 8. So that would be 8 over 240. If you like to see the numbers. But otherwise, it's going to be the same thing. So this graph is coming here. The first, at the first, you are going to get the intercepts. Then you go down here, okay? You go down here, you get a minimum. Then you go to the intercepts, and eventually you go up here. So the graph is going to be, you copy graph. You see, this is going to be a copy of the graph. Because they ask for the 2 complete cycles, but they said start from t equal to the 0. T equal to the 0 means you go to the right. Any question? So they are a copy of each other. Then make sure you get something nice. You see these intervals must be consistent. Okay, so we did graph it, and they ask for the maximum and the minimum. Okay, for which value in part B you're going to get a maximum and the minimum. As you can see, this is it. You see the maximum would happen at t equal to the 0 and in 1 cycle. Okay, that's what. So the maximum, so you can answer. So that was the B. So you can say that the maximum value, the maximum, okay, value of V of t occurs, if you like, at t equal to the 0, okay, and t equal to the, if you want to get all these 2 that you have, okay, they didn't say anything, but to complete it, at t equal to the 0, 1, at t to the 160, 2, and at t equal to the 8 over 24, 240.
Can we reduce that?
Sorry?
Can't we reduce that?
Yeah, I just write
Okay.
it down already.
Okay.
It's going to be 1 over 30, yes. So what's going to be the final answer? T equal to the 0, t equal to the 0, 160, and 130, okay? Because they say in part B. In part B, we have, this is the graph that we got on part B, to cycle. Okay, so analyzing these type of ideas is the one that would like to understand or to take from this course, really, because this is what we need in future. The others, the formulas, you can check the formulas, but these are going to be different from one problem to the other one. We're going to make it a little bit more interesting later, but it's a nice application. Okay, so we give you one. We give you exactly one of these when we get to your next quiz. Okay, get to know it, and it's interesting to see this type of application. So these techniques is the key, really, because if you want to go with the old-fashioned one, that if you want to graph a function, just collect some points, make it t-charts, okay, that would be quite something different with these numbers. You see, with this situation you're going to have, it's not going to be helpful. But as I told you, if you get to over of these, if you want to take calculus, especially calculus 2 and 3. You will get some part that is going to be so useful for you when you put them together. We have some other ideas that the graph is just the beginning. So we don't have time. We want to have a good idea of the graph, quickly graph it, and then we go for it. Okay, so this is one situation. Any question? Now, so this is a sine and a cosine that we are going to have. There is another type of graph that we're going to consider, the equations. You see, this next one, again, it depends on your background or what you want to do. But my suggestion is I stay with this one, and I can do, or you can do at the end, any graphing without any extra information you're going to have. What is the other one? The other one is, look at this one, these angles that we have. We have something we call it shifting, if you like. You know that we have the x and the y. So you can move the x to the right, or you can move the x to the left. You can move the x to the right 2 units. You can move it back 2 units, x plus 2, x minus 2. The value of the y go up and down. You may go up, instead of y, we have y plus 2. Going down, instead of y, y minus 2. These type of ideas, okay, you can use these ideas in order to sketch the graph of the function. We do it in college algebra mostly, or sometimes we ignore it. But this method, okay, this method doesn't need anything else. That would take care of everything for you. I'm going to show you one example to see without any previous idea how we're going to graph it, just using this one. And you don't need to bothering about those shifting, okay? So what would happen is, you see, when we do this type of function, when it's just cosine x, when it's a cosine x, you have the origin, you see, we say the sine start from the origin and the cosine up and down. Sometimes you shift this number, okay? You shift your function to the right or to the left. And then if you do a little of algebra, it's the same thing, and you can do it. Let's give one example to explain it, just to show you that we are not going to make it complicated. We stay with our method, and we are able to do all the problems. Okay, let's check one.
Work.
Yes, question. Okay, so let's try this one. In your book, they give you a complete section for this one, but we are just staying with our method. So that is the one, two. Oh yeah, I'll give you this one. Again, you will see one of them in your next quiz. You see, we want to graph this function. Okay, we wanted to find something similar to the one they did, find the range and the domain, or just use this expression so that when you want to do your assignment, the same thing, find the amplitude, altitude, and the period. Okay, and the period of this function of, okay, the function is, look at this one, y equal to the 3 sine of, instead of 2x, we have 2x minus pi. You see, something extra, we call it shifting. So find the amplitude and the period of this and graph it. And sketch, okay, the graph, or its graph. This is a function. Okay, let's see what we're going to do and what's going to be there. I just wanted to do just same method that I talk about without all those type of idea of shifting from algebra. You see, let's do it as we did for the other one. What is the situation we're going to have? Solution. You have nothing to worry about the range. This is a 3, so the amplitude would be just 3, a equal to 3. Unless it's a negative number, use the absolute value. Otherwise, it's the same number. Then the period, the b is 2 again here. Okay, so the period is going to be what? It's going to be 2 pi over 2. 2 pi over 2 would be pi. Okay, so that give you the pi. Now, the situation that we are going to have is what we do. We usually divide this pi by 4. Okay, divide this pi by 4. You see, let's do it. This is t equal to the pi. You divide it by 4. That give you pi 4. Okay, that give a pi 4. And then for the other problem, the range that we will consider was 0 and pi 4. 0 and pi 4, and then we graph it. But look at this one. You see, your variable over here is not x, it's a 2x minus pi. It's a 2x minus pi, so the situation is different. So this means you are not going to start from the 0. So you have to check to see what is going to be your starting point, because your x would change into the 2x minus pi. It's like if you call this one z. If you call it z, you have 3 sine of z. When it's a sine of z, z is between 0 and 2 pi. Okay? But what is x? So what you're going to do is you have to do an extra job, if you like. The extra job is going to be to find one period, okay? To find the interval. The interval for one cycle, in this method. So what you're going to do, you're going to let that z, which is a 2x minus pi, this would be, because this must be between, okay, this must be between what? Must be between 0 and 2 pi. Because if you call it z, the period of the sine function. The period of the sine function is 0 and 2 pi. Now solve for x. If you solve for x, what's going to be the result? Add the pi to both sides. So that gives you a 2x, and this is going to be the 2 pi, okay, plus pi. So that gives you 2x greater than equal to the pi, and this is going to be 3 pi. Okay, this would be 3 pi, and so your x would be what? So you divide by 2, so that gives you the pi half, less than equal to the x, and this is going to be less than equal to the 3 pi half. So this means for this function, okay, for this situation you're going to have, your x must be between pi half and the 3 pi half. So this means one interval, okay, one cycle should be in this format. This is going to be the pi half and the 3 pi half. Okay, so this is going to be the interval, is the interval for one cycle. Okay, so instead of 0 that we start usually, yes, it's going to be 0 if you change this one into the z. Okay, but it's 2x minus pi. Okay, 2x minus pi. So your starting point must be the pi half. Okay, you already got the pi t equal to the, okay, you have this interval. I repeat it again, that your t was pi that you divided by 4, which is going to be the pi 4. So what you're going to do is you start from the pi half and then you move on. So the first number is going to be pi half. You move it to the right. How much? Pi 4. Okay, that's pi 4. So this is going to be pi half plus pi 4. In practice, you just divide it and you will see it. But I want to show you. So this interval would be part is going to be pi half, comma, 3 pi 4. And you know that this is 90 degrees. If you add 45 to the 90, that gives 135. So 3 pi 4 is going to be just 135. Okay? And then you continue to get all those 4 sub intervals. Okay, so similarly, this is going to be the situation I'm going to have. Okay, similarly, you are going to have what? This is going to be the pi half, comma 3 pi 4. That is the first one. The second one is going to be 3 pi 4. This is 135. If you add the 45 again, so that give you pi. Remember, you must get to the what? You must get to the 3 pi half. Another, so this is going to be pi. Another pi 4, 225. That gives 5 pi 4. Then it's going to be 5 pi 4. Okay, another pi 4. That gives you 6 pi 4, which is 3 pi half. And if you find it, then you can divide those 4 subintervals to get these numbers. So these are going to be the crucial interval for your function now. And now this is going to be your graph. You see? Now the period that you are going to be interested in, remember, this is your period is pi half and the 3 pi half. So you can start as usual and just change it. Okay, this is it. This is a 0. And this is, for example, a 2 pi. Okay, and the numbers that you need is the pi half and the 3 pi half. So I'm going to identify this is my pi, and this is the 3 pi half. Sorry, that's a pi half, and that's a 3 pi half. But what you have to do is you have to divide between the pi half and the 3 pi half into 4 parts. Remember, each part is pi 4. So pi 4, pi, 3 pi 4. 1, 2, 3, 1, 2, 3, 4. Okay, so that's a pi half, that's a 3 pi 4, that's a pi, and that's a 5 pi 4, and to get the pi half over here. Okay, so I should use a better measurement. It's a 3 pi 4, and this is a 5 pi 4. Okay, 5 pi 4. So the range was a 3, so 3 on the top. 1, 2, 3. So this is going to be 3 on the top. 1, 2, 3. This is going to be 3 down the bottom. Okay, the negative 3 and the positive 3. So what type of function do we have? We have the sine. You see? So what we're going to do is your starting point is here, the pi half. It is a sine. Remember, the sine starts from the 0, the origin. But your interval, the first point is the pi half. So the 0, your 0 would be the pi half, because you shift it. For the next number, for the sine, remember, you go up. You go up. So this is going to be your next point. For the next number, you go down. Okay, you go down for the next number. So that was a 0, down. You go to the intercepts, then down. So intercepts, down. So this is going to be down, and then intercepts. So this is going to be the graph of this function. You see, this is going to be your graph. If you started at the origin, that is just the graph of the sine function. But what you did is you just shifted to the right. Shifted to the right. You see, look at this one. How much? Pi. That's going to be the situation that you're going to have. So with this method, really, we can graph all of them. We don't need anything. If you just expand this one a little bit, that would give you a better shape, if you like. So instead of working from the 0 up, intercepts down, up, you start from the pi half. You start from the pi half, you go up at the first number, 3 pi 4, 135. Then you go to the intercept, the next number, 180. Then you go to the minimum, next number is 3 pi 4. You see, this is the one. You start with the pi half at the x-intercepts. 3 pi 4 to give you the maximum. Pi give you the intercepts. Okay, pi give you the intercepts. 5 pi 4 give you the minimum. And the 3 pi half give you the maximum, if you like. So this is going to be a situation that we're going to have with these shifting ideas. Okay, and you can move it to the right or to the left to get more, okay, more function. It's not difficult to see. If you want to move it, each section is 45 degrees. You see, look at this one. 1, 2, 3, 4. 1, 2, 3, 4. Copy this one. Okay, how are we going to copy this? Okay, you go to the minimum. Okay, you go to the minimum. This is going to be the minimum. You have to go to the origin. You see, to the origin. You go to the maximum. You go to the maximum at this point, and you come back to the x-axis. You see, one more copy. Because the difference is 45 degrees. You see, this is 90, 45, 0, 45, 45, 45. So you can have a various copy of your function. And nothing to worry about. That method would, it works all the time to get the numbers. The other option is the option that we have to focus on those type, in algebra or college algebra or pre-calculus is the idea of the shifting, but this one is much easier. Again, the advantage of this method is these numbers. If you are going to be in calculus, it takes you so much time to be able to find these 4 subintervals. And over here, you get it free, really. You didn't pay anything. You get it right away. Okay, so that's going to be the idea of the shifting. I'll give you another example, when we get to the to your practice one, if you like, to get the something for the cosine or the sine. Okay, so that gives you the idea for the sine and the cosine. If we get time, we come back, and the other one would be the result of the sine and the cosine, all the other graphs, especially the secant and the cosecant. So we would like to get to the chapter 5 because there are quite a lot to do over there. Then if we get time, and we come back and give you more graphs. But otherwise, this is the foundation that you need for this graph. Okay. And yes, if you want to do it with the shifting, this is another, if you are good on that idea of the algebra, you see, yes, idea of the algebra is you have to graph this one first. Okay, y equal to the sine of the 2x, you will do this one first. Then when it's a negative pi, is shifting to the right. So if you graph your function, you see this is your function, but you see this is it. Somebody asked for the shifting. You see, you graph this one first. Y equal to the 2 sine of the 2x. Okay, which is going to be easy. Let me explain it. Maybe some people like it. You see, I have y equal to what? Y equal to the 3 sine of the 2x minus pi. If you don't like that method, this is another option. The option is if you know those algebra, so you graph this one first. You see, we graph this one first. Not difficult. You identify the period is going to be 2 pi over 2. Okay, 2 pi over 2, that give you pi. Okay, you divide it by 4. So this is it. So one period would be 0 and pi. Okay, and you divide it by 4. So that gives you pi 4. And you know that the interval that you're going to have. So this is going to be your graph. more room. Okay, so this is going to be your graph. For example, this is going to be the 0, and this is going to be your pi, if you like. You divide to 4 parts. So these are going to be your 4 parts. Okay, so that's a 3. So you go up 3, 1, 2, 3, 1, 2, 3, -3, +3. Okay, and you start from the bottom. So that give you the maximum, the intercepts, and the, okay, then the minimum. It's a sine function, so start from the origin. Start from the origin, up, intercepts. So this is going to be your graph. Okay. This is going to be the graph of what? This is the graph of the y equal to the 3 sine of the 2x. Okay. Now, in order to get your graph, so what are interested? We are interested in this one. Sine of the 2x minus pi. You have to take this graph and shift it to the, when it's a negative, you shift it to the right. How much? Pi. So all these points that you see over here, you have to shift it to the right as much as the pi, if you like. Okay, to get your new parts, if you like. Okay, so for example, this is the one that you have is 0 here. Okay, you shift it to the right, so this is going to be, for example, the starting point, if you like. Then you just move the other points exactly, you know, the same type, if you like, and then you can graph your function. Okay, if you shift it almost, you get, you know, get the same one. This is going to be 0, then we have to have something else. Okay, and then we just change them into those. Let me see what we have here. Okay, we go up to the 3 pi half. The number that I got is 0 pi. Yes, we go to the 2 pi, and then, you know, these are going to be the one that you shift. So that was a pi 4. Okay, the pi half. So the 0 would be here, a little bit of the pi 4, and you get those numbers, and then you can, you know, can start from here. The same thing, for example. Okay, so that give you almost the same thing, if you like. Yes, you can do the shifting. This type of method, as I told you, is going to be, both of them are going to be good one, but this one would be nice if you want, because we are going to do something else in future regarding these intervals. That would be very important for us. But on the test, we don't mind. If you are good on those shifting, just use the shifting to graph it. But I prefer the first one for the application from calculus point of view, but you are free to use either one. Okay, that's it. Any question? So make sure these, especially application one, just a good feeling of how we deal with everyday life problems. Okay, that's very important for us to know it. Just, you know, a couple of these cases would be fine. I don't believe that, you know, some people, they say, oh, we're using graphing calculator, and sometimes in calculus they let you do it really, which is, yes, it's good when you are done, you're working with the project, etc. But now we are in the course of understanding these subjects rather than, you should be able to analyze the graph in future. These intervals are important for, you know, if you want to measure physics, electrical engineering, etc. Anyway, we continue next time. Any question? Have a good one. Take care. I grade your quiz test. I will post it next week. Chapter 5 is all formulas. We try to get as much as we can so that we can give you a next quiz on chapter 5 mostly. That's going to be the ideal. Okay. So yes, I saw that video that you sent me, but I haven't got time to look to it, Yeah, I checked that. Thank you for sending me that video. Okay, have a good one and take care. Bye-bye.